Not that far away from the planet, in most cases, researchers have found a new planet known as Proxima B. Recently, it was discovered by stargazers, keenest picture yet captured of Proxima B, using the notable James Webb Space Telescope. This planet orbits the star that is closest to our Sun. A fantastic image provides a remarkable look into a world outside our nearby planetary group, raising questions and excitement among researchers worldwide. Yet how did this telescope accomplish such an achievement? Could this picture provide insight into a spot that could have conditions appropriate for life? At last, what does this new discovery mean for how we might learn about exoplanets and the vast universe beyond? Join us as we explore the newly uncovered, clear picture of Proxima B that the James Webb has captured. This strange planet, Proxima Centauri b, sits inside the vastness of space surrounding its star, Proxima Centauri, which is only 4.2 light-years away. This faraway world was captured from Earth, sparking our imagination and raising inquiries about its similarity to our planet. Might it, at some point, be likened to Earth, facilitating seas and abounding with life? Adding to the interest, Proxima Centauri isn't alone in its journey. It shares an orbit with another sizable planet, Proxima Centauri c. Proxima Centauri b gets about the same energy from its star as Earth gets from the Sun, making researchers curious about whether it's possible this faraway planet has water or can support life. While we explore the endlessness of space, we encounter various exoplanets, worlds circling stars other than our Sun. With a bewildering 206 trillion stars dispersed throughout the universe, the opportunities for these exoplanets appear to be endless. Some of these planets wander freely through space, like enormous migrants. Proxima Centauri b stands out as a unique riddle in this broad array of celestial bodies. Its year is surprisingly short, lasting just 11.7 Earth days, and it circles its star about 20 times closer than Earth does to the Sun. Thus, one side of the planet is frequently washed in sunlight, while the other remains in endless darkness, adding to the planet's strange and possibly wondrous nature. Proxima b was initially found using the radial velocity method, an earth-shattering procedure in finding exoplanets. This method depends on noticing the subtle movements of a star caused by the gravitational pull of a circling planet. As the planet circles its star, it creates a small but discernible movement, causing the star to shift slightly in its orbit. Space experts spot this development by carefully studying changes in the star's spectral lines, a phenomenon called the Doppler shift. For Proxima b, these small changes in the star's spectrum reveal the presence of this far-off planet, displaying the radial velocity method's effectiveness in uncovering worlds outside our nearby planetary group. The discovery of Proxima b was a critical accomplishment, as it confirmed the presence of an exoplanet within the habitable zone of the closest known star to our Sun. This discovery ignited tremendous interest among researchers, specialists, and space fans in general. They are eager to explore the potential mysteries Proxima b could reveal and what this means for how we interpret the universe, and the possibility of life beyond Earth. Proxima Centauri b is an infinite wonder worth marveling at. Picture Regulus, Canopus, and the companions of celestial Proxima Centauri moving across the vastness of space, forming the closest star system to our own. As we look into the night sky, Regulus and Canopus merge into a brilliant guide that unites everyone in the Centaurus constellation. These stars rank as the third most brilliant, stunning us with their splendor at a maximum magnitude of 0.27. But it's only the modest Proxima Centauri that holds an intriguing secret. Additionally referred to as Alpha Centauri's red dwarf from the Type M class, it lives only 0.21 light-years away from its brighter companions. To put it into perspective, that's multiple times farther than the distance between the Sun and Earth. The name Proxima Centauri, meaning closest star in Latin, highlights its status as our closest celestial neighbor. Back in 1915, Scottish cosmologist Robert Thorburn revealed this divine diamond to the world. No matter how close it is, Proxima Centauri remains problematic for the untrained eye, boasting an apparent magnitude of 11.13, far beyond what the naked eye can see. Despite the visibility limit of 6.5, red dwarf stars like Proxima Centauri are enormous forces to be reckoned with, effectively producing energy through strong processes of internal convection. This star will maintain its position as a main sequence star for another 4 trillion years, exhibiting a lasting brilliance that spans the ages. However, the concept of habitability around Proxima Centauri has its fair share of challenges. Being a flare star, Proxima Centauri experiences sudden and unusual eruptions of energy. Its lower mass hints at the possibility of a habitable zone where life-friendly conditions could exist, but one much closer to the star compared to our Sun's habitable zone. Enter Proxima b, a planet situated within this zone at a distance similar to Earth's orbit around the Sun. But appearances can be deceiving. Proxima B faces intense ultraviolet radiation, many times stronger than the sunlight reaching Earth. This extreme radiation poses a danger even to hydrogen atoms, imperiling the stability of essential elements like nitrogen and oxygen. Furthermore, simply occupying the Goldilocks zone doesn't guarantee a sustaining environment for life. Proxima B might not have the vital environment necessary to support life, manage climate, or cultivate a surface suitable for water. Without the protective shield of a vigorous atmosphere, any potential life forms on Proxima B would be exposed to the brutality of space, significantly reducing the likelihood of life as we understand it. The mission to uncover the secrets of Proxima B, despite its challenges, remains a driving force in space exploration. Among the tools fueling this invaluable research, the James Webb Space Telescope stands out. Launched toward the end of 2021, after numerous delays, this cutting-edge telescope holds the promise of shedding light on one of the most tantalizing questions in cosmology: does life exist on Proxima B? The path to uncovering Proxima B's truth is far from easy. To use the James Webb Telescope effectively, scientists underwent significant adjustments to ensure the accuracy of its images. According to a renowned theoretical physicist at Harvard, Proxima B requires a nuanced approach. Situated inside the habitable zone of its star, the planet has the capacity to absorb and produce infrared rays, vital to life-sustaining radiation, making it detectable by the James Webb Space Telescope. This advanced instrument can capture faint light from the planet's surface, aiding researchers in their search for signs of water or an atmosphere. The crucial question of whether Proxima B has water plays a significant role in interpreting this nearby exoplanet. Water, a fundamental element for life on Earth, if found on Proxima B, would greatly increase the likelihood of the planet being habitable, or at least capable of supporting some form of life. Proxima B, located within its star's habitable zone, receives roughly the same amount of solar energy as Earth receives from the Sun. However, because of how close it is to its red dwarf star, the planet faces intense. However, that hasn't stopped scientists and engineers from dreaming. Ambitious projects like Breakthrough Starshot aim to send small, lightweight probes equipped with cameras and communication devices toward Proxima Centauri at a fraction of the speed of light. If successful, such probes could reach the Proxima system in just over 20 years, transmitting invaluable data back to Earth about the environment of Proxima B. This represents a dramatic leap in space exploration, moving from observing distant planets to potentially visiting them, even if only robotically. It's a bold vision, one that requires solving monumental engineering challenges, including propulsion, navigation, radiation shielding, and ultra-long-range communication. Yet the potential rewards are just as monumental, a close-up study of an exoplanet that might harbor life. In the meantime, Earth-based observatories and space telescopes continue to gather data. Spectral analysis, photometric readings, and thermal imaging all help researchers build a clearer picture of Proxima B's atmosphere, rotation, and surface conditions. Each piece of evidence brings us one step closer to answering a question humanity has asked for centuries: are we alone? Proxima B is more than just a scientific curiosity, it's a symbol. It represents the frontier of human knowledge, the edge of what we know, and the possibility that somewhere out there, in the cold black of space, another Earth might be waiting. The search for life beyond Earth has evolved from myth and imagination to science and exploration. And Proxima Centauri B, our nearest potentially habitable neighbor, stands as a beacon, silent, distant, and mysterious, inviting us to reach beyond what we know and to never stop asking the questions that drive our greatest discoveries. For now, we watch. We listen. We calculate. And above all, we hope. Creativity in space are driven by imagination. Exploration forward presents potential solutions, like solar sails. These ultra-thin sails could revolutionize space travel, pushing spacecraft at amazing speeds and possibly reaching the Proxima Centauri system, where Proxima B is located. In 20 years, this technological leap brings the dream of exploring an Earth-like exoplanet within our lifetime tantalizingly close to reality. The discovery of Proxima B has rekindled human curiosity about the universe, instilling a renewed sense of hope and fascination. It stands as a testament to our relentless desire to venture into the unknown, to learn something new, explore worlds, and contemplate the existence of life beyond our home planet. While the James Webb Space Telescope is a marvel of modern astronomy, it is not without limitations. Despite this, its extraordinary ability to observe celestial objects and shed light on the potential for life on exoplanets like Proxima B is remarkable. It grapples with challenges in interpreting the presence of atmospheres and identifying conditions conducive to life. Proxima B's atmospheric resemblances to Venus provide a stark reminder that an atmosphere alone does not guarantee habitability. Nonetheless, the telescope's exceptional ability to detect even the faintest signs of life, such as bright orbital mirrors, a potential development on Proxima B, highlights its vast potential. Our universe, with its enormous and enigmatic breadth, holds something surprising, a number of planets eager to share their secrets. These celestial bodies, exoplanets, orbit stars far beyond the reaches of our solar system, displaying a remarkable variety in their sizes and shapes. Some are giant gas monsters like Jupiter and Saturn, while others resemble our very own Earth. Gas giants stand as perhaps one of the most enchanting classes of exoplanets. Planets with structures similar to Jupiter and Saturn, frequently referred to as super-Jupiters, loom so massively that they render Jupiter, the largest planet in our solar system, small by comparison. Alongside these immense entities reside the hot Jupiters, dangerously orbiting gas giants close to the stars they host, exposed to extreme temperatures capable of melting metals. Studying the characteristics of such planets reveals a world on fire, filled with wild storms and searing heat. But the exoplanet category boasts diversity beyond these giants, including Neptunian exoplanets, similar in size to Uranus and Neptune. Among them are the hot Neptunes and small Neptunes, smaller cousins settled closer to their host stars than their larger kin, shrouded in mysterious atmospheres that continue to challenge our understanding. The quest to understand distant exoplanets like Proxima B has led scientists to develop cutting-edge technologies that expand our understanding of the universe. Discovery continues to advance methods such as the transit method, where astronomers observe the slight dimming of a star's light as a planet passes in front of it. This technique has changed our ability to identify and study planets outside our solar system. It has revealed thousands of exoplanets, many of which exist in the habitable zone of their stars, where the conditions might be suitable for liquid water to exist. These discoveries fuel our imagination and bring us closer to answering one of the most profound questions in science: are we the only ones in the universe? Astronomers are always improving their efforts to locate biosignatures, indicators that could reveal the presence of life on distant worlds. By studying the atmospheres of exoplanets, scientists can identify gases such as carbon dioxide, methane, and oxygen, all of which are associated with biological processes. The James Webb Space Telescope, with its powerful infrared capabilities, is expected to be instrumental in this area of research, enabling the detection of these gases even on planets that are light years away. If scientists are able to confirm the presence of biosignatures in the atmosphere of an exoplanet, it would provide strong evidence that life could exist elsewhere in the universe. Yet even as we look outward toward the stars, the search for life in our own solar system is ongoing. Moons of planets like Mars, such as Europa, Enceladus, and Titan, and other far-off bodies have been studied for signs of liquid water, potential organic compounds, and habitability. While these bodies are much closer to home, they still present challenges when it comes to exploring the possibility of life. For example, Europa, one of Jupiter's moons, is believed to have a vast ocean beneath its icy surface. Scientists are hopeful that future missions to Europa could shed light on whether microbial life could exist in its subsurface ocean, a finding that would have profound implications for our understanding of life in the universe. The role of robotics in these endeavors cannot be overstated. Rovers, landers, and orbiters have been essential in gathering data from Mars and other planets. The Perseverance rover, for instance, is currently exploring Mars, searching for signs of ancient life and collecting soil samples that may one day be returned to Earth for analysis. These missions are pushing the boundaries of space exploration, enabling us to accumulate information that may, in the future, lead to the discovery of life beyond Earth. In the coming decades, space exploration is likely to shift toward the search for more Earth-like exoplanets, with missions concentrated on studying the environments and surfaces of these distant worlds. The development of new technologies and the continual advancement of space telescopes will enable scientists to make even more detailed observations of exoplanets, bringing us ever closer to addressing the question of whether or not we are truly alone in the cosmos. As technology progresses, the dream of interstellar travel, once confined to the realm of science fiction, begins to appear on the distant horizon. Concepts like the Breakthrough Starshot initiative propose sending tiny spacecraft, equipped with light sails, to nearby star systems such as Alpha Centauri at a fraction of the speed of light. Though this endeavor remains experimental, it symbolizes humanity's bold ambition to reach beyond our solar neighborhood. These missions may take decades or even centuries to come to fruition, but they ignite the spark of possibility. The idea that future generations might witness the arrival of a human-made probe in another star system inspires innovation and international collaboration on an unprecedented scale. Meanwhile, Earth-based efforts remain critical to the broader mission. Ground observatories, artificial intelligence, and data processing algorithms help analyze the vast troves of astronomical data generated by space telescopes. AI, in particular, is increasingly being used to sift through noise, recognize planetary patterns, and predict the characteristics of exoplanets, helping astronomers focus their search more effectively. Equally important is the role of education and public engagement. As we uncover more about distant planets and the potential for alien life, the need to inspire a new generation of scientists, engineers, and dreamers becomes ever more urgent. Outreach programs, planetariums, and science fiction all play a role in cultivating wonder and imagination, encouraging young minds to look up and ask, "What's out there?" Ultimately, the search for life beyond Earth is more than a scientific pursuit, it is a philosophical and existential journey. It forces us to confront our place in the cosmos, to re-evaluate what it means to be alive, and to consider the deep connections between all forms of life. If life is found elsewhere, even microbial, it would profoundly alter our understanding of biology, evolution, and the uniqueness of Earth. And if, after centuries of searching, we find nothing but silence, that too will shape humanity's destiny, underscoring the rarity and preciousness of life on our pale blue dot. Whether the universe teems with life or we are alone among the stars, the journey of exploration continues. It is driven not only by the quest for knowledge but by a deep, unquenchable yearning to connect with the unknown, with each other, and with the mysteries that lie far beyond our sky.